Well, thank you very much for taking the time to be here today. I really appreciate that. Can you guys hear me okay in the back without? Okay, awesome. I hate mics and standing still. So really appreciate you guys braving the entire snowstorm, Snowmageddon, but we get these every other week, so we're a little immune at this point in time. I really appreciate all the help from Chris Brazier. I know he was the original one that sponsored the event, so thank you, Chris, for setting this up. Aubrey Tapai, who's done all the event coordination here, which may not seem like a lot when you walk through the lobby there, but it takes a lot to put all these people together. So main purpose on the presentation here, we're going to try to kind of speed this up because we want to get you guys back on the road to make sure you don't have too long of a commute getting back there, and make sure you're nice and safe. But I want to talk a little bit, just kind of give you a brief overview on Trimble and kind of the buildings group and the construction group. So that'll be real brief, and then we'll talk about the Westminster Phase 2 building, which we just completed last November. So, and some of the solutions we implemented on there. I'll highlight a few places for you guys to get more information, and then we have some experts out in the lobby, so you guys can get some actual hands-on time, play with some of the different solutions out there, and experience some of these new technologies that are coming into the construction market. So, unfortunately, we don't have the machines driving today. The CEC, the civil folks said they would grab some folks and put them on the machines if you really want to, but I don't know if I'd recommend that right at the moment. So they do have an emulator out there, so we can play like we're on the excavators and so forth. All right, so we'll jump into this real quick. I'm going to kind of fly through some of the standard Trimble slides overview here, but one of the big ones I wanted to point out on here is the over 800 construction professionals that are within the Trimble construction group. So we have a lot of folks that came from industry, and we've all kind of gone through the heartaches and the pains on the job site, and we all came basically to Trimble to try to make the processes easier. So when we look at the individual operations that are out there within civil and geospatial and some of the building operations, every little click that we can reduce times a couple thousand or tens of thousands of customers saves a lot of time for everybody worldwide. So it's really important for us to implement a lot of these processes and these solutions on our own building project as well. The way we're divided up here in Trimble is kind of into 5 major divisions: agriculture, buildings, civil engineering and construction, geospatial, which is kind of what most people equate to civil or to surveying, and then we've got transportation and logistics. So we're going to concentrate on the middle 3 today because that's kind of your guys' bread and butter, and that was the mainstay of the products we were able to implement on our own construction projects. We've got a lot of emerging technologies out there too, so heavy into the utilities and mining and other operations. So every day I come to work, I find out something new, and it's just like going to college for me, so I love it. I love going to class and trying to learn every day. So I get to learn new things every day that didn't know we did yesterday. We're into seismic monitoring and all sorts of different stuff that we don't have time to get into everything. But so the title of this slide, Construction is Hard, seems kind of oversimplification, but the reality is if you came from industry, you've gone through the construction projects. I was a university student. My dad was head of a couple departments at the university. I'm used to very strict, scientific methods, and I got out of the construction industry, and it blew my mind of how jacked up the entire process was. I mean, it was, literally trying to stop people from knife fighting in the parking lot, and deliveries were never there, materials were never there, people weren't being safe even though it was for their own good. It was just a mind-blowing process, and we just kept on repeating the process over and over again. So that's one of the reasons I'm at Trimble, honestly, is because I got tired of the construction industry. I was looking at going back to college just to go do something else, and got the opportunity to build this building right now that we're sitting in, and was the on-site technology manager for this building. And that's right after we bought Tekla, and we bought SketchUp. We bought a few other programs and kind of put the entire buildings portfolio together, and I got to play with the laser scanners and total stations I was already really into, but seeing all those different solutions in one project, there was no other way I could go back to the old way of doing things. So instead of trying to push from within in my company and be a lone ranger on some of those projects, I decided to come over to Trimble and try to push it out to all the different companies out there, especially on the educational front. So firm believer in trying to push as much of this information and the processes out to you folks as well, so we can train that next generation on the processes that people are already using today. So you can see on this slide, really we're talking about trying to create constructible, content-enabled 3D BIM models, basically, that we can connect either through the web or through the machines, out in the controllers, out in the field if we're doing layout and surveying and so forth. But the big thing here is actually having constructible details on the model. So when we're out there actually building these items, we want to get down to the nut and the bolt and the rebar and all the spacings and every piece that's going to have to go into building a building. I know when I was involved in the construction, we got into 3D modeling on the BIM coordination and so forth. BIM kind of took off, I'd say, in the early 2000s, started to gain some traction right before the recession. The recession hit and everybody stopped investing. And one of the reasons they stopped investing is because BIM got a bad name out there, because people were just making pretty models. Walls weren't necessarily sized right. They'd forget all the X-bracing or the supports that go out there for your curtain wall framing, or on the bathroom supports, they forget that steel, or they wouldn't detail the spacing on your VAVs. And so they spent all this time doing a 3D model coordination in the office, and then they send it out to the field, and you can actually build by it. So superintendents, project managers, like, well, what do we spend all this money on a BIM model for if we can't actually use it out in the field? So that's what we're really trying to concentrate on, is making it down to the manufacturer's level, every nut, every bolt, and we can place that out on the job site down to a 1/16 of an inch. So heavy tech adoption, we've got a lot of studies on returns on the investments. Obviously we can't take a project and take it from getting 2 or 3% profit to getting 15% profit, but we can incrementally make these processes a lot better. So every time we can improve even one subcontractor trade just a little bit, it brings out a huge value for everybody downstream, including the owners that operate the building later. We're talking a little bit about wearables. That's kind of a big trend now in the construction industry, as well as IoT. So having that information and all those sensors on various pieces of equipment or materials, or the building automation system, having all that information readily available now. Now it's just a problem of trying to aggregate all that data and make it usable.
Quick question?
Yes.
On that previous slide, you have AEC firm hiring data scientists, data officers, and blockchain experts. What is Trimble doing to support that effort?
I don't know right at the moment, but we'll hold off on questions probably until the very end, and then we'll jump in. But good question. Okay, so we're going to talk a little bit about the Phase 2 building. If we get a chance after this, after you guys are done with some of the hands-on demo stations, we can take a quick tour, walk through that area as well. A few stats on that building. Just completed in November. We completed this building in May of 2013. Saw immediate need right after that we needed another building. Tried to put it off as long as possible, and then finally put it into action about 2017 and finished it here late 2018. We've got about 118,000 square feet in the new building. This one's about 125,000 square feet, so we condensed a few things, made it a little bit tighter on the cubicles, but still had plenty of space out there. We did core and shell level 4, so we have a potential leasee looking at that space, and then we'll finish that off at some point, either for ourselves or for our leasee. Lead silver on the second building. This one was a lead gold since it was a greenfield site. A little bit easier to get lead gold on a brand new building when you don't have anything else existing out there. If you get a chance, I don't know if you'll be able to see it through the snow, but we have a huge array of antennas and GNSS receivers up on the roof of this building and on the roof of the other building for testing and verification and support for various equipment across the world. And then one of the big things, we're actually already renovating building 1. So if you got a chance to go to the bathroom, you might have seen some temporary partitions over there. As we've only been here about 6 years, and we're already seeing needs to reconfigure some of the spaces for better, bigger conference rooms or more conference rooms. The gym's getting a lot bigger. So that, trying to recruit for the younger generations. Physical activity is a big thing out there. So keep that in mind as you're working with your students on potential projects as well. So here's a list of some of the Trimble technologies we implemented on this project. We ended up with over 55 different Trimble technologies we used on that single project, and I think over 70 different instances. So robotic total stations, for instance, would be used by the general contractor as well as maybe all the MEP trades out on the job site. So I got a couple of trades that basically doubled up on some of the technology. But we won't hit all these. I'm going to talk about a few of them that I think will be more interesting for you and your students, and try to highlight the ones that we've got some demo stations out there as well. I did put in websites on this, and then if you registered, we've got your email. We'll send you the slide deck so that you have access to the information. It's mostly just images, but I did give a lot of resources in there for websites and other places you can go grab more information. So hopefully that'll be helpful. So under buildings, one of the mainstays we have right now is a 3D platform where we can federate and aggregate all the different models from various different sources. We call that Trimble Connect. So you can get more information at connect.trimble.com. But we can basically take Revit models. We've got a Revit publisher in there, AutoCAD, Bentley, IFCs, DWGs, SketchUp files, Tekla files, put them all into a web browser, federate them so they're all in the right coordinate system and they're all in the same model system. And then we can actually take those and start doing sections or clash detection all in a web browser. So, you know, one of the issues we have on taking BIM out to the field is those folks don't know how to get into 3D models, right? If you're not using it every week or every month, you forget what keys do what, and it becomes really hard to get in there and utilize those 3D models effectively. So we try to make it, take these models down to the easiest level factor, take it into a web browser. They can do section cuts. They can get the data behind every one of those pieces of model information. So in this example here, we've got a stair cut there. May have had an issue with the connection into the stair core. Superintendent or foreman can actually grab that view from, you know, maybe their BIM manager or somebody set up a view that's already got all the models federated. They can take that view and then section it down to the certain area they want. Grab that item, grab the IFC information, highlight it, send it a to-do back to their project manager and say, here's the stairwell, we'll have an issue. Here's the embed that that didn't get placed, or we've got an issue with this embedment that doesn't catch the stair stringer. And so instead of trying to write that all out and trying to describe where this is, they go to the 3D model, they highlight the image, they've got all the part information right behind it, and they can send this off right via the web and get their answers that way. It does keep track of everything that anybody does in here, so if you accidentally delete a file, we can still go back and grab that file at any point in time, or if you're keeping track on your MEP coordination, making sure that they're updating models, or you have the latest and greatest background from the architects or engineers, you can grab that really easily here and find it actually in that activity log. So just like Facebook or LinkedIn, you can try to capture what everybody's doing in here and kind of manage the process from a single pointer perspective. Utilize Trimble project site on this project as well. So are any of you familiar with Prolog or teach Prolog in your curriculum? A few of you? Okay. So this is kind of the next generation of Prolog. So web-based project management, costs, safety inspections, field inspections. But the big part of this is since we're still all tied to contract documents, you know, due to permitting requirements, we still have to have PDFs. We can take all those PDFs, aggregate them here, and then as you get new versions of those PDFs, it'll automatically find the characters. So if it's a new sheet A101, it'll find that. It'll automatically say, okay, we're overlaying that on the old sheet A101. Take all the hyperlinks, those transfer over to the new sheet. If you have any submittals or any RFIs or ASIs, any of those items are linked into that original sheet. All those transfer up to your next drawing. And now you have one sheet of music that everybody on the job site should be playing from. So I know digitization of PDFs is kind of the biggest thing, actually has changed the construction industry in the last 5 years. Prior to that, I mean, almost every job site I went to, I had 40 subcontractors that were all playing off a different sheet of plans. So now at least we have one source they can go to. Hopefully the GC or whoever's trying to keep up on those documents are keeping up with the changes, but at least they have one location that they're going to, and somebody's not walking off with my permit set of drawings that have all been stamped and trying to use that as the latest and greatest drawing so they can build by. Trimble SketchUp, so some people still refer to this as Google SketchUp, or they may still have Google SketchUp installed on their computers. So we've got these guys back in about 2011. So when I was at JDUN, we used SketchUp for every one of our logistics models. We'd put these together, throw some 3D models on there, do some massing around for some of the other buildings out there, or if you got on a tight postage stamp job site downtown, you know, you could figure out the exact logistics on your one-way points of travel, We got down to showing where the portalets are going to go, where all the dumpsters are going to go, where a laydown yard was going to be, and making sure all those items are out of the way of new utilities that are going to get installed, so we don't have to move the trailers and shut down the job site office for 2 or 3 days. But it makes a big difference because now I can easily change that when a new utility is coming through, or we have to change gates. I just go into the model, update it, and everybody can easily understand that without just looking at a plan and trying to visualize what the 3D aspects are there. We used it for the interior finishes in here to try to make some decisions on colors and seating arrangements, how everything was going to come together, even on the landscaping. So we went through a couple different iterations on our patio out there, and I wish it was yesterday, so it was 80 degrees and nice and we could all go out there. We've got some nice barbecues and so forth, but making some decisions on how those spaces were going to come together and how they were going to feel aesthetically as you're walking through there in an easy-to-use 3D platform, right? So you don't have to be an expert modeler. We can go to the warehouse. There's over 4 million models on that 3D warehouse. So you can just go grab whatever model you want to. If you want a Cat D6, you can throw that in your model. You want a Lieber tower crane, you can go and grab and throw that in your model. Or if you want a T-Rex, you can grab that and throw that in a model, which for some reason in our training sessions, the kids love to throw dinosaurs under their job sites. I think that's how most people feel during the course of a project. Recently, they introduced a web version of SketchUp, so almost all the same functionality that you have on the desktop version, you now have in a web browser. So launches, this is an image of a building we're working on in Boulder, so about 60,000 square feet. We've got 2 stories in there, all the finishes already installed in this model. I'm able to open this up on a web browser, zoom around, make real-time model decisions in there. So the other day we were trying to explain to one of our IT folks on, if we put this server room over here, we're going to have to route some duct over in this certain area. It might impede their walking space. He's kind of hemming and hawing, couldn't figure out exactly what we were talking about. I just grabbed the tool, grabbed a box, extruded it, showed him exactly where the ductwork was going to go. He's like, oh, yeah, that'll work, right? So one of those things that wouldn't necessarily pass the mustard, or they get into the space and didn't really realize what was on those 2D drawings. We're able to show in 3D on the fly in real time and make real time decisions. So it makes a huge difference on those aspects as well. SketchUp for higher education, so K through 12, they've got state programs, so basically anybody in a K through 12 program can get SketchUp for free. For educators, you guys have licenses for free, and then we work with a lot of universities that are already in here to make sure you guys have lab licenses. So if you don't have that, make sure you talk to Allison or Chris Brazier or Stephen Griffin over there, and Chris Dizon is out there as well. So talk to those folks, and if you don't have SketchUp working in your program, and this is not because I work for Trimble, please go get it because it's one of the easiest 3D modeling platforms out there. They've got some boot camps coming up around the country as well, so there's a link in the slides that we'll send out. You can sign up for that. It goes through the basics for the first couple days, and they also have some really good courses online through the LMS. So great program. I taught my mom how to use it in a couple hours so she could design her kitchen, and that's exactly what they ended up building. So when I say it's easy to use, I really mean it, even for me. We also have a lot on the estimating platforms. So we've got WinEst and Vico and ModelLogix on the general contracting estimating platforms. We also dive really deep into the MEP platforms. So when I'm out there talking to university students and high school students, I really stress trying to go into the trades. I know a lot of us are trying to push onto the general contracting methods, but if you start looking at where the dollars go on the projects, the MEP trades are typically making more than the general contractor themselves. So if we really want to push up their salaries, we need them to actually look into the MEP trades as well. So Accubid and AutoBid on the sheet metal and MEP systems, we can really automate the entire estimating process. So if we want to make sure that we actually make money on this entire building project, we're going to start off with PDFs because we're not usually going to get a 3D model from anybody. So we take those PDFs, we can start tracing out the systems by individual systems. So if you're looking at chilled water or hot water or any of the various items out there, they basically pick the system, they trace out the PDFs, they show the risers, the runs, they even get down to the valves and reducers and so forth. But we're actually taking that information from the manufacturer's level of detail. So we've got, I think, over 8 million different components that we keep up with on a daily basis in the MEP trades. And so they're taking that down to, not just the size, but also the price and availability and so forth, so they actually can feed that into their estimates. When they get done tracing these systems out, they can actually take a cut sheet or a bill of materials, and they can go price that out manufacturer by manufacturer to figure out what the best fit is. So really trying to automate that entire estimating process. SysQ, this actually is a product that sits on top of Revit. So when I talk about that 8 million different model components from the manufacturers, we can actually take a lot of those into the 3D model environment, into Revit, and start pulling those individual manufacturers' items into that model. So it's not just the individual sizes and all those pieces, but actually where the hanger is going to go, right? So again, when we talk about BIM kind of falling short on some of these projects, a lot of times it's because they forgot to put in all these hangers and the attachment points, and we're hanging things underneath 6-foot sections of ductwork, and there's nowhere to actually support these systems. So when we're installing these and drawing them in 3D, we're actually getting every one of those points and every one of those hangers into the systems, and then we can export that out to our robotic total stations as well, that we'll talk about here in just a minute. Kind of skipped around there, but Accubid's kind of the big one on the MEP estimating side. Specifically went for electrical back in the day, but that's starting to push into the mechanical and plumbing systems as well. So some nice things on the Accubid is it's actually doing automatic character recognition again, so you can actually pull off those symbols and do automatic quantification, so it really makes your estimating a lot easier. And then again, getting down to the manufacturer level of detail on every one of those parts and individual components. Tekla Structures, is there anybody in here using Tekla Structures in the programs? A few of you. Really awesome modeling platform for structural components. I got the opportunity to go to training back in 2012, and I think that makes me just dangerous enough to still open it. But within a week, I was able to model this entire building down to the nut and the bolt and the plates and the fillets on the welds, and that was my first week of ever touching the program, first week of getting training. So I went in there, did their basic training during the day, and then at night for a couple hours, I'd go grab the cut sheets that the structural engineer gave us and drew it right in 3D down to the concrete level and rebar level. So awesome platform. It probably has about 55–60% of the market on the structural steel detailing segment, and they're pushing into cast-in-place concrete, rebar detailing, structural steel, all the way to curtain walls, and basically any structural items and elements we can actually throw in here, and you can actually see the little bends on your cold rolled studs, when you're putting these into the 3D model. So we're taking it down to the nth detail. The two images you see on the left are actually a laser point cloud overlaid with the 3D model. So we took some scans and we took those directly into Tekla, and now we can actually look at the rebar as it exists right before we pour in concrete compared to the design rebar as it exists in the design model. So you can do some quality control assurances, make sure you have the right clearances out there, or make them adjust the rebar out in the field if you see an issue or you're doing inspections and they forgot some bar, got the wrong size bar out there. We can find that pretty quickly. A couple Tekla resources, so there's free versions at campus.tekla.com. It's somewhat a pared down version, but they do have some training information there as well for you, some videos to go through. Also put a link to their full LMS that's on the website, so they get into down to how to detail rebar and make your specific steel components and so forth. So it gets really in depth on that side of it. And then they're going to have a Tekla base camp out in Pittsburgh, right, in late August. So if you get an opportunity, a good user group out there, and they really take modeling pretty serious. Something that we're not demoing out here, but I thought you would be interested in is Trimble CrewSite. So this is a product that's been out there for 3 or 4 years now for us, but this is actually personnel tracking out on the job site. So when we first initially launched it, we started out with basic RFID badges that you can go in there, tag that, or mount it to your hard hat. And we had a series of sensors you can go out there and make sure people are flowing through certain entrances. We actually integrated that with turnstiles. So if you haven't gone through orientation, you didn't get your badge, or now we've switched over to Bluetooth beacons as well. So if you haven't gone through orientation or you aren't safety certified, we can't let you through that turnstile. So if we have a lot of projects that are requiring super secure job sites, so data centers, chip manufacturing facilities, some universities are actually installing this if they're adding on to dormitories or something like that. So we're trying to make sure that We know where people are in the job site. Then we can set a series of sensors around the job site or on the stairwells and so forth, so we can actually start tracking where individual trades are and how many people we have on certain levels. So it makes a big difference when we're trying to make sure that we've got all the right people in the right place and matching that up with our schedule to make sure we've got the crew sizing appropriately. The big part of this, though, is for safety requirements. So as a superintendent or a safety officer or when the foremen are walking around, they can have this app on their phone. They can walk out there and they can scan a certain worker from 30 or 40 feet away with their phone, and they can figure out if that worker is actually Hilti Paddle actuated tool certified, right? And maybe they shouldn't be using that, but I can, without stopping them and asking them or trying to go pull their card from the filing cabinet back at the job site, they can just click on the phone, yep, they're certified, ready to go. Or if we have an emergency situation, somebody hits a gas line, or we've got a major issue on the job site, storm's coming up, they can notify everybody on the job site, simultaneously say, notify everybody that's on the job site via their cell phone that we've got a storm that's 10 miles out, and we've got lightning in the area, we need to get everybody buttoned up, get everything tied down, and everybody off the roof. So a really nice, easy way to kind of manage the job site, manage your safety, and look for anybody that might be left behind if you have first responders coming out there for emergency situation. So robotic total stations, we've got a couple different versions of our robotic total stations and the controlling software that goes behind that. So this is Trimble Field Link. So this actually integrates with Tekla, with SketchUp. We can take DWGs, IFCs, DXFs, SketchUp files, and even digital PDFs. And we can take those and use those as the background for our layout. What's nice is they don't have to be trained in classical surveying. They can go in there, they can look at this program. It's really easy to understand. We can actually go out there and train folks on how to use this that have been in the trades for years, never done layout, and we can get them up to speed in a day or two depending on their level of capability, which is a really nice, easy way to get them out there. They get full 3D immersion in the model if they want to go into that realm, and then it guides them right to the point. So there's a little image of the hockey puck that guides them down to the certain area that they're trying to go to. And then based on your tolerances, if you're laying out anchor bolts, you might want to say that doesn't go green until it gets within a 1/16 of an inch. You can update your tolerances there as well. But yeah, easy to use program, and we can literally lay out points on the floor using a laser beam. It'll point right to the location. It'll adjust for any of those elevation differences because you're always going to have a little bit of variation on that floor. It'll pinpoint that exact XY position, and it does that all in 1.5 to 10 seconds, depending on your surface and what you're trying to go to. So versus the old way of taking a tape measure off of one wall and putting an X, and taking a tape measure off the other wall and putting an X, and plumb bob up to the ceiling and trying to figure out, where's my ladder and where's my scissor lift to try to get over that point. Every time you do that the old way, it takes about 10 to 15 minutes to install a hanger for one of these MEP systems. So the new way, we take the total station up to the deck above before we pour that concrete. We tell it to point to that hanger that we maybe designed in Siskiyou or whatever it was. We say, okay, lay out the hanger for the ductwork. It literally shines the laser to the right spot, corrects to the right XY position, and then they can go shoot a Hilti blue banger right through the deck, and they've got that hanger installed basically in 30 to 60 seconds. So a huge time savings out there, especially when they're taking all that information. They have the entire 3D model at their fingertips with all the different systems, and if anything pops up that might be an issue, they could find that really, really quickly. Laser scanning, so there is a TX8 out in the hallway. This is a awesome laser scanner. This is actually an image of the TX8 up on the roof of this building, and I'm probably too close to the parapet, so I probably shouldn't show that image too much, but we actually scanned the job site down below us, and we're probably about 250 to 350 feet away from various areas of the job site, but I did a 10-minute scan on one end of the building, got about 500 million points, did a scan from the other end of the building, got another 500 million points in about 20 minutes. We stitched all those together and had a 3D point cloud so dense we can tell if we have number 4 or number 5 rebar sticking up into that stair core. So without ever stepping foot on the job site, not having to have any, minor safety issues, we can really quickly scan a job site for progress information, right? And trying to figure out where that rebar is on the job. We've got a lot of contractors and subcontractors now that are making it standard operating procedure to go scan their concrete decks before they pour to understand where all those rebar pieces are, where all the post-tensioning cables are, where the electrical conduits are that are buried in that concrete slab before they cover it up, or before we put in sheetrock or put in our ceilings. And now you've got an accurate as-built of where everything was. We can even take models into our RealWorks is the post-processing software we use for our laser point clouds. We can overlay those models with the 3D point cloud, and then we can do some heat mapping on here to figure out how close, or if we have anything missing, if anything got installed that's incorrect, we can see if there's any issues out there. So the image on the upper right-hand corner is actually looking down one of our stair shafts. So we did 2 little 2-minute scans down below there. Didn't have to get on a lift or have any safety issues. Scanned the stair core, processed it really quickly, and then you can see that they had a bust in that formwork that actually created a little bubble in that concrete. So that could cause issues with our stair attachments or our stringers, or if that was an elevator core, right? We might not have rails that attach right. But we can really quickly find that information with that 3D model and the 3D scan and have a lot of information at our fingertips really, really quickly. Kind of an image of showing, taking that full 3D point cloud, combine that with the model, and then that should help us make sure we get everything installed and correctly out in the field as well. All right. Doing okay? Timing? Good? Wrap it up? Okay. Geospatial? Getting the hook already. All right. I don't know if I can talk faster, but I'll try. So I do get a lot of folks telling us, we're taking jobs away from surveyors, but I disagree completely. We were actually trying to help the surveyors out. And this is the reason why we still need surveyors out there. This is a slow-moving fluid that we're trying to build on. So we have lots of items out there. We've got Trimble Access, so we have a table out there you can check out with the software for surveyors. They have all sorts of different modules. We've got the SX10, which is one of the baddest laser scanners / total stations on the market out there. This thing can hit prisms up to 4 miles away, or you can use one of the 5 cameras to zoom in on a certain item at 1,000 feet down to a 1/16 of an inch. So really cool total station / laser scanner as well. This one does 28,000 points a second instead of 1,000,000 points a second, but a lot of times 28,000 points a second is good enough. So they've got integrations with the onboard cameras as well, so you can get the point cloud information associated with an image, post that up to a web browser, and let engineers or architects or product managers take some measurements directly off that image in the web browser. Tim's cart is a mobile mapping cart that we have available, so it combines laser scanning with photos, with inertial sensors on a wheel. It's not going to be as accurate as one of those tripod-based scanners. We're going to be down to 1 to 2 centimeter type accuracy, but we can hit 100,000 square feet in 4 to 6 hours. So really quickly get as-builts for the 99% of buildings that we have terrible as-builts already existing, if at all. Lots of rotating lasers through the Spectre brand. T4D on the monitoring side, so again, they've got some seismic monitoring that'll be integrated with the total stations or with GNSS, so you can track if a building's moving, or if you have some issues like downtown LA or out in San Fran, right, we can monitor how much those buildings are moving, reflecting in a day. On the CEC side, so the civil engineering and construction, we've got Trimble Business Center, and this actually integrates with the geospatial side as well. But we can create all those subsurfaces, we can feed those out to the machine, and now the driver is literally just steering, and the blade is pitching and rolling and cutting based upon that 3D model we have on the surfaces. So it really takes a lot of that guesswork out of being an expert grader. And we can take somebody that's operated for a couple weeks and knows the safety operations, we can make them as good of a grader that's been doing it for 20 years if they're trying to cut to final grade, let alone cost savings on diesel and maintenance and so forth. So they have some demo stations over on the far south side. I highly encourage you to take a look at those. They have some new operations out there and tilt sensors on the GNSS. So they've got videos of them taking the GNSS pole almost to 90 degrees and still get an accurate reading at the tip of the pole. So some really cool operations out there as well. Some images of VisionLink and trying to integrate the real as-time reporting on surfaces and what those machines are doing out there, what your pieces of equipment are doing in the field, what's being used, and down to the individual piece of equipment, how long it was being used on that day, how much idle time it had, when it was actually doing production, fault codes, right? We've got a ton of information at our fingertips nowadays with these machines. Photogrammetry, so I know a lot of folks are getting into UAVs. We're not supposed to call them drones, but unmanned aerial vehicles or surveying vehicles. But we've got some online processing for those UAVs for stitching the photogrammetry together and creating a point cloud out of that. And once we have that point cloud, so you fly during the day, you process for a couple hours or overnight, depending on how much data you actually have collected. And then at the end of you come back in the morning, now we can actually go take cut fill analysis, slope analysis. It'll flatten out trees and equipment and other things that are out there that don't need to be interpreted, but we can actually get real-time information and do historical time lapse of those flights across the job site as well. Construction logistics, basically get into monitoring in the concrete or asphalt down to the number of rotations and how much water you put on that drum, right? So really quickly get all the information on those expendable items out there. All right, I'm almost done. Mixed reality. So how many of you are using HoloLenses in your curriculum? A couple of you? All right. If you haven't had a chance to check this out, I think we've got 4 of them for demonstration out here. We're using the Trimble Connect app for those HoloLens devices. So we can actually take any of those different various models, federate those together, and put them into an actual work environment. So this video that we have some snippage of here is on YouTube. If you look up Trimble HoloLens or Trimble and HoloLens, basically this would be one of the videos that come up. But we actually took, in the building over across the way here, we took a 20,000 square foot section of the building. We took the 3D models for the structure. We used that to actually place it in a 1-to-1 format on the job site using plane-based registration. So locked it in there in a couple minutes and then turned on the MEP systems and put it on the foreman for them to go walk around. And the first thing, they put it on their head and they look up and they start looking at their systems, and the first words out of their mouth is, "Holy shit, this is awesome." And they just start chasing their systems, right? And they're looking for clashes and making sure the hanger's in the right spot. These guys have no 3D modeling experience whatsoever. They had almost no training whatsoever. We just put the hard hat on them and they're using the real model in the real world that quickly. So really awesome to see in real time. Sight vision we have out there as well. So this is more for exterior use, where the HoloLens is going to be more interior use. And we had an announcement here a couple months ago about joint combination with Microsoft to help produce the next version of the HoloLens. So this is the HoloLens 2. It's going to be the XR10. So this one will flip up, a whole bunch of improvements. But this will be a great mainstay in the market here, coming pretty quick. So highly encourage you guys to take a look at the demo stations, get some times for the hands-on, talk to the experts out there. I know enough to be dangerous, but wanted to give you some resources and quick little snippets so you know what to go look for. And with that, I'll turn it over. Sweet. Thank you.